Hey everybody, what's up? Mr. Miller here bringing you another instructional video, and as always I hope you're doing absolutely fantastic today. In this video we're going to be looking at simplifying rational expressions, and I cannot emphasize enough how important it is to be able to factor. That's why we spent a week reviewing factoring polynomials. If you're still not quite up to scratch with factoring, that's okay. You can go back and look at the video that I made on factoring. You can get extra help from me, but it's going to be very important because the next couple of weeks we're going to have things that we need to factor, and not only factor, but factor very quickly, because in the problems we're going to be given, there's going to be a lot of stuff to factor in order to get to the answer, and you're going to want to be on, you don't have to be, lightning fast like Flash, but you need to be on the quick side. So let's dive right into it, shall we? Simplifying rational expressions. Here we go. So first of all, it might be good to know what exactly is a rational expression. A rational expression is the quotient of two polynomials. Ooh, fancy language, very fancy. Quotient polynomial. Woohoo! Let's take a look at some examples to demonstrate that definition. So here are two examples of rational expressions. The first one is 2n over n minus 2. The second one is x squared plus 3x minus 10 over 3x plus 2. Quotient, basically, we're just going to say that means a fraction. And polynomials, you really don't need to know what the definition of a polynomial is, but basically what it means is all of your exponents on your variables are whole numbers. Whole numbers are numbers like 0, 1, 2, 3, 4, etc. And if you take a look, for instance, at 2n, notice that the exponent is a 1. It's not a fraction. It's not a negative number. It's a whole number. 1 is a whole number. 2n would be considered a polynomial. In the downstairs, notice that the exponent on n is also 1. All right, n minus 2 is also a polynomial. X squared plus 3x minus 10. All of the exponents on your variable are whole numbers. A 2, a 1. We don't have something crazy like negative 3 halves or something like that. So that's basically what a polynomial is, and I'm giving you a very loosey-goosey definition of polynomial there. Again, for this topic and what we're going to be doing the next couple of weeks, it's not necessary you know the definition of a polynomial. What is necessary is, as I've said before, is to be able to factor things. All right, when we're simplifying rational expressions, we're going to say it's in simplest form when the numerator and the denominator, or as I like to say, upstairs and downstairs, have no common factors other than 1. That means nothing else can be canceled out. If you're claiming your rational expression is in simplest form. Let's take a look at a very simplistic example to crystallize this. Simplify 9 over 15. Now, you're probably looking at that and saying, gosh, that's so easy. I'll just divide the top and the bottom by 3, and that's going to give me my answer. And you know what? You would be correct. Nice job. But let's take a different approach to show what factors they have in common. We can break up 9 as 3 and 3, and we can break up 15 as 3 and 5, right? Because we recognize 3 is common factor to both 9 and 15. What can we do now? Notice that we have a common factor of 3 in the upstairs and in the downstairs. So we can cancel out a pair of 3s, 1 3 in the top with 1 3 in the downstairs. What's left when you do that? When the 3's cancel out, that really becomes 1 over 1. So picture a 1 being above and a 1 being below. 1 times 3 is still 3. 1 times 5 is still 5. So our final answer would be 3/5. With me so far? The same idea we're going to be doing when we're giving rational expressions where the things in our rational expression have variables and they're polynomials. Kind of the same idea. Before we get into some examples of simplifying rational expressions, it's good to have a little bit of this terminology down. Now, a factor is in between a multiplication sign. Factors are things that are being multiplied together. An addend, on the other hand, is separated by addition and subtraction symbols. Addends are in between addition or subtraction signs. Now, if we take a look at some examples down here to solidify factors versus addends, take a look at the first example here, 3x times x plus 2. 3x is multiplying this quantity in parentheses, x plus 2. 3x and x plus 2 are factors. But because x plus 2, the x and the 2 are separated by an addition sign, x and 2 are considered addends. Okay, you see the difference there? In between the 3x and the quantity x plus 2, you can picture a multiplication dot being in between. 3x and x plus 2 as units, 3x as a unit and x plus 2 as a unit are factors. But when we look at x plus 2 and separating the x and the 2 from each other, not treating them as a unit, they're separated by a plus symbol, x and 2 would be considered addends. And there is a really good reason why I'm taking the time to explain the difference between a factor and an addend. We'll get to that in a little bit. How to get a rational expression in simplest form, okay? Here are your steps. These are going to be your basic steps to simplify a rational expression. The first step, factor the numerator completely, the upstairs. Step 2, factor the downstairs completely, the denominator. Or if you like, you could start with the denominator and then factor the numerator. So the point is we need to factor the upstairs and the downstairs before we start canceling stuff out. Which brings me to step 3. Once you've factored your upstairs and downstairs, you're going to cancel out any common factors, if any. Now, I want to say that it is possible that you'll take time to factor your upstairs and factor your downstairs, and nothing at the end of that factoring process will cancel. It's going to be rare that that happens, but it still can. So I don't want you to get it in your head that every time you factor a rational expression, it's going to guarantee stuff is going to cancel out. That's not true. You need to factor, look at your upstairs and downstairs and see if there are any common factors that can be canceled, and if they can be, you cancel those factors out. What's left over after that canceling is your final answer. Now, this is very, very, very important. You ready for this? Very important. We never, ever, ever cancel addends. Ever. Don't do it. Don't do it. Let's take a look at a correct way to simplify a rational expression. This is a very simplistic example, but I think it will bring it home as to what I mean by correctly simplifying a rational expression. Take a look at the upstairs. We have 5x minus 10, right? What's common to 5 and 10? What's the GCF, in other words? GCF. The GCF is 5. So let's take 5 out of that thing, and what does that give us? That's going to give us 5 with x minus 2 in parentheses. Make some sense? If we were to distribute the 5 back through, we would get 5x, and then 5 times negative 2 is negative 10. It would take us right back to here. Now, what factors are there in common? Are there any factors in common? The answer is yes. 5 is a factor because it's multiplying the x minus 2, and this 5 down here with the x is multiplying the x. So here, 5 and 5 are both factors. Factor, okay, makes sense. We can cancel those 5s out. Huzzah! Final answer. What's left over? Because that's all we can cancel out. X minus 2 over x, right? Beautiful. X minus 2 over x. Now, let me show you the wrong way to factor 5x minus 10 over 5x. Same problem, but let's say that instead of factoring first, you say to yourself, oh, wait, 5x and 5x. Hey, they match. I'll cancel those, right? All right, cancel those 5x's out. Wrong! Why can't you do that? The answer is the 5x in the upstairs is separated by a minus. This 5x as a unit is an addend. You can't cancel the 5x in the upstairs with the 5x in the downstairs because the 5x in the upstairs is not functioning as a factor. It's factoring as an addend. But let's just see what happens if you kept going with this. It's going to be wrong, but let's see what happens. So let's say then you go, oh, okay, 5x over 5x, I get 1 minus 10. Nope, that's not going to work. Negative 9? No. Why? Because you canceled these two things out that you can't. These cannot be canceled out. Shame on you. Don't do that. Don't do that. Oh, you're too kind. You're too kind. You've been a great audience. What we're going to do now, guys, is we're going to take a look at some examples together. And what I want you to do now is go ahead and click on that next video, take some notes, and if you have any questions, call me over. Be glad to help you. Keep up the good work. You're doing really well. Thanks. Bye.